Today, we will be learning about linear electron transport. What is photosynthesis? Well, photosynthesis is the process in which photoautotrophs use and convert the light's energy into usable energy to make their own food. Photoautotrophs use two light-capturing complexes known as photosystem 1 and photosystem 2. The first steps in the electron transport chain happen within the thylakoid membrane of chloroplasts. There are three membranes in the chloroplast: the inner membrane, outer membrane, and the thylakoid membrane. Linear electron transport and ATP synthesis is a process that occurs in the thylakoid membrane of a cell. This model of the eukaryotic thylakoid membrane illustrates ATP synthesis by chromosomes. The four major protein complexes shown in the illustration include photosystem 2, the cytochrome complex, photosystem 1, and ATP synthase. The blue arrows indicate the pathway the electron takes. Step 1. Oxidation of P680. Photosystem 2 absorbs light from the antenna complex, which culminates to the formation of P680. This energy causes one of P680's electrons to change from ground state to an excited state. This results in the excited molecule P680'. This excited electron then gets transported to the primary acceptor molecule, leaving P680 with a positive charge and the primary acceptor molecule with a negative charge. The positively charged P680 molecule is so electronegative that it is able to oxidize from a water molecule through an enzyme subunit known as water splitting complex. The water molecule splits into two hydrogen atoms, two electrons, and one oxygen gas molecule. There are now two electrons traveling in the electron transport chain, one from the P680 molecule and one from the water molecule. Step 2. Redox of PQ. PQ then acts as an electron shuttle by traveling through the lipid bilayer and donating these two electrons to the cytochrome complex. Once PQ donates electrons to the cytochrome complex, it releases protons into the lumen, which increases proton concentration in the complex. Step 3. Electron transfer to photosystem 1. The mobile carrier known as plastocyanin then shuttles the electrons from the cytochrome complex to photosystem 1. The first electron gets added to P700+, making it to a neutral P700. Redox of P700. The electrons that are transported to photosystem 1 get excited through the absorption of a photon of light. This reaction creates P700'. The chlorophyll from P700' transfers its electron to the primary electron acceptor of photosystem 1, which then forms P700+. P700+ now acts as an electron acceptor and is then reduced back to P700 by the oxidation of plastocyanin. This is a redox reaction. Step 5. Electron transfer to NADP+. The primary acceptor transfers this electron to a protein known as ferredoxin. Ferredoxin is an iron-sulfur protein. The oxidation of ferredoxin results in the transfer of the electron to NADP+, which then reduces to NADP. Formation of NADPH. A second electron from photosystem 1 is transferred to NADP by another molecule of ferredoxin. This second electron, alongside a proton H+ from the stroma, are added to NADP by the NADP+ reductase to form NADPH. NADPH now carries two high-energy electrons. Step 7. Results of transport. The pathway the linear transport takes is unique because it does not pass electrons onto NADPH. The proton gradient is used to generate ATP with the same kind of ATP synthase complexes found in the mitochondrial membranes. Linear transport results in the formation of ATP and NADPH.